Next second semester exam review video for Algebra 2, we started to do trigonometry after we did exponential functions, logarithms, and sequences and series. The first thing we reviewed was right triangle trigonometry, which is going to be a very, very short review. So remember, you have 6 trig functions, and we use the mnemonic SOHCAHTOA to remind you that sine is equal to opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And you can use those 3 trig functions to solve right triangle trig problems. Make sure that your calculator is in degree mode. It could still be in radian mode from when we were graphing trig functions. So be careful on the exam to make sure that when you're doing triangle problems that your calculator is in degree mode. Now, we also learned that cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. Choshaka. Okay, now with these 6 trig functions, sine, cosine, tangent, cosecant, secant, and cotangent, we can use them to solve for missing sides and missing angles. And I'm just going to do one example of each, and there are plenty of review problems for you to do. So someone's asking me in this first example to find the measure of this side. Well, notice that relative to the 38-degree angle, this side is opposite, and this 9 is hypotenuse. So I know that I can use sine to solve this problem. So I say the sine of 38 degrees is equal to x over 9. Now, multiply both sides by 9, and you have x equals 9 times the sine of 38 degrees. But again, if you're going to solve this with a calculator, you need to make sure that your calculator is in degree mode before you go punching buttons. So I'm going to type in 9, and then I'm going to find my sine and 38. And as long as I'm in degree mode, it tells me that x equals approximately 5.54. So that's the measure of that missing side. Okay, now, notice in my second example over here that x is the measure of a missing angle. So do you remember when you're trying to find a missing angle, that's when you use your inverse trigs on the calculator. So can I say that x is equal to, oh, wait a minute, we need to establish this. 5 is opposite, and 9 is adjacent. And so I know to solve this problem, I need to use tangent. So I say x is equal to inverse tangent of opposite over adjacent. So now, with my calculator in degree mode, if I press that trig button and find that inverse tan and type in 5/9, 5 divided by 9, calculator will tell me that that angle is approximately 29.05 degrees. So I'm hoping you remember how to use your 6 trig functions to find missing sides and missing angles for right triangles. Okay? Now, after right triangle trig, we also learned about the law of sines and the law of cosines, which we found out was actually new to you. You did not do these in geometry. So we'll make sure that you have sort of a reference sheet that you're allowed to use in the exam. We have the law of sines that says for any triangle ABC, so if I draw a triangle ABC, stop laughing. Here's vertex A, here's vertex B and C, here's lower A, lower B, and lower C. The law of sines says that A over the sine of A equals B over the sine of B equals C over the sine of C. And these are the 3 cases when you use the law of sines. If you're given 2 angles and the side between them, 2 angles and the side not between them, or two sides and the angle not between them. Then you have the law of cosines, and I taught you that you could think of the law of cosines two different ways. These formulas up here will help you find missing sides, and these three formulas down here are what you do to find missing angles. So I'm hoping you sort of remember that, as this is just a review video. So let's see what kind of problems we have. Oh, by the way, for the law of cosines, use the law of cosines if you're given the side, side, side case, if you're given the measure of all three sides, or if you're given two sides and the angle between them, called the side angle side case. So let's see. Now, for these two examples, and we're hoping that that's enough, but you'll get plenty of review problems, let's see what we've got here. In this first example, I'm given 14 is the measure of one side, 16 is the measure of another side, and 35 is the measure of the angle between them. Well, this is referred to as a SAS case. Okay, well, let's see. According to this, SAS means that I'm going to be using a law of cosines to find a missing piece. So let's see. What if I said, what do I want to do? What if I said I want to find the measure of side A? Well, with the law of cosines, I have A squared equals B squared plus C squared minus 2BC cosine of A as one of my formulas. So I can say that A squared equals 14 squared plus 16 squared minus 2 times 14 times 16 cosine of 35 degrees. Well, you see, in the SAS case, everything is on the right side of the equal sign, so that whole quantity can literally just go into the calculator. So I'm going to take a minute to type this in. 14 squared plus 16 squared minus 2 times 14 times 16, and then I'm in degree mode, so now I can hit cosine 35. And the calculator gives me 85.0199. So I think I'll just call it 85.02. Well, remember, that's the value of A squared. So A is equal to the square root of 85.02. And so let's see. Calculator tells me that the square root of that is 9.22-ish. So I have found the measure of this side to be approximately 9.22-ish. So that was a law of cosines problem. I had to figure out by what was given to me which formula, whether I should use the law of sines or the law of cosines. Okay, so now come over to this second example. This time I'm given the measure of an angle, the measure of another angle, and the side that's between them. This is an angle side angle case, and if I refer back to my notes here, it looks like angle side angle is going to force me to use the law of sines to find a missing piece. Okay, so let's see here. What if I said find the measure of side C? Okay, well, the law of sines says that A over, wait a minute, let me start over. I could pick this out. I could say C over sine C equals A over sine A. Well, the problem is I don't know sine of A. But remember that the sum of the three interior angles of a triangle must always equal 180 degrees. So if I add 42 and 85 and I get 127, If I take 180 minus 127, what's that going to be? 53. So I found A to be 53 degrees. So now I can say C over the sine of 85 equals 9 over the sine of 53. So now I can solve this equation for C. I can cross multiply C times the sine of 53 equals 9 times the sine of 85. C would equal 9 times the sine of 85 divided by the sine of 53. So I'm going to grab my calculator and I'm going to type that in degree mode. 9 times the sine of 85 divided by, oops, I want to put that division there, close that parenthesis, and then divided by the sine of 53. So I'm pulling up sine of 53, and the calculator tells me 11.223-ish. 11.23-ish is the measure of that missing side. So that's a quick review of right triangle trig, the law of sines and the law of cosines. You definitely need to attack that portion of the review sheet to get some more practice problems from these very limited number of examples.